In this question, it is given that there is a liquid which cools down from 70 to 60 degrees Celsius in 5 minutes. And we have to find out the time which it would take to cool down from 50 to further cool down from 60 to 50 degrees Celsius. It is given in the question that the temperature of the surrounding is 30. So the trick which I was mentioning in the previous video, we will use that trick, and that trick is very useful in these kind of questions. So that we will use the rate of cooling. So we know that the rate of cooling of the body, which is the change in temperature upon time minus dt by dt, is proportional to, or we can write it as is equal to C delta T. So we'll use this directly. So we know that the body is cooling from 70 to 60. So we are neglecting this negative sign. So we are using 70 minus 60 divided by 5, which is the time. And that is equal to C. And this is temperature of body minus temperature of surrounding. So in the value of temperature of body, we have to take the average value, 70 plus 60 by 2, minus the temperature of surrounding is 30. So this is the first expression, and let us simplify it. It would be, this is 10 by 5 and this is equal to C, and this is 65 minus 30. So this is 2 is equal to C into 35. So this is equation number 1. Now we have to find out the further time it would take to cool down from 60 to 50. So 60 minus 50 upon the time t will be equal to C, and now again delta t would be 60 plus 50 by 2 minus 30 is the surrounding temperature. So this is 10 by t is equal to C, and this is 55 minus 30. So this is 10 by t and it is equal to C into 25. Okay, so you can, this is equation 2. So if we divide 1 and 2, 1 divided by 2, so you can see that 2 upon, this is 10 and this would be t, is equal to 35 upon 25, and this is 5 and this is 7. So this is 2 and this, so t is equal to 7 minutes. So this is the answer. Now we move on the next question. In this question, it is given that a hot liquid is kept in a big room, and according to the Newton's law of cooling, the rate of cooling is plotted against the temperature of the body T. So we have to find out that which of the following curve is the correct representation of rate of cooling versus temperature of the body. So we know that rate of cooling is directly proportional to the temperature of the body minus temperature of the surroundings. So let us suppose that it is y and it is equal to some constant C into, this is x and this is some temperature T0. So you can see that this is a straight line which is going up and starting from the negative y-axis. So the correct answer would be option number B. Now we move on the next question. In this question you can see that there is a body which is kept in a room which has a constant temperature of 30 degrees Celsius. The heat capacity of that body is 2 joule per degree Celsius, and the initial temperature of that body is 40. We have to assume that Newton's law of cooling is valid here, and the body cools down from 40 to 38 in 10 minutes. So we have to first of all find out that in further 10 minutes it will cool down from 38 to which new temperature. So it is given that it cools down from 40 to 38 in 10 minutes, and in further 10 minutes we have to assume that it cool downs to T degrees Celsius, and again time is 10 minutes. So we'll again use that trick which I have already demonstrated in the previous question, that 40 minus 30 upon time is in fact 38 upon time is 10 minutes, and it is equal to C, and that average temperature of the body, which is 40 plus 38 by 2 minus the surrounding temperature, which is 30. So this is 2 by 10, it is equal to C, and this would be equal to 39, and minus 30, it is 9. So this is equation number 1, and from 38 to T, so it is 38 minus T divided by 10, and it is equal to C into 38 plus T by 2 minus 30. So if we divide these two equations, this is equation number 2, so it would be 2 divided by 38 minus T is equal to 9 divided by 38 plus T by 2 minus 30. So you can simplify this equation, and let us simplify that it is 2 divided by 38 minus T. So 2 divided by 38 minus T is equal to 9 upon, I'm again writing it down here, 9 upon, it would be 38 plus T by 2 minus 30. Now solving this equation, we would get 38, this is 38 plus T minus 60, and this is 342 minus 90. So 10T will be equal to 364, and T will be 36.4. So the correct option will be option number B. We know, and in the next question it is asked that the temperature of the body is denoted on y-axis and it is plotted against time on x-axis. So which of the following graph is correct? So obviously option number A is correct. We have already drawn this graph in the derivation of Newton's law of cooling. And in the next question it is given that when this body attains a temperature of 38 degrees Celsius, it is heated again by some heater, so that it again reaches to 40 degrees Celsius in 10 minutes. So we have to find out the total heat required by the heater. We know that when this body is at 40 degrees Celsius, it is taking 10 minutes to cool down to 38 degrees Celsius. And in those 10 minutes, it is releasing a heat of C delta T. So C is 2 and delta T is 2. So it is releasing a heat of 4 joule through radiations. Now, in this process, when body is getting heated from 38 to 40, it will keep on radiating the energy, and in 10 minutes in the range of this temperature, it would radiate 4 joule. Now the heater is increasing the temperature of the body, but due to the radiation of heat, the temperature would be decreasing. But heater has to increase the temperature of the body. So heater has to compensate the loss of heat done by the body through radiation, and heater has to give some additional amount of heat to increase the temperature of the body. So to compensate the heat loss, heater has to give a heat of 4 joule, and to increase the temperature of the body, heater has to give a heat of 4 joule again. So the total heat which is required by the heater is 8 joule. So this is the correct answer. Thank you.